we are solving each component for the exact conditions at which they're going to be operating. Just like in the way that you think of holistic medicine, when you go to the doctor, they'll tell you, hey, take some ibuprofen and then wait for your body to get better, right? They are looking to cure the symptoms, not really the root cause. When you model everything at once, you get to see that pump is not working well, so this is why we have those results down the road, or we have some fouling in the heat exchanger. And you get to investigate this to see what's going on and what impact that is currently having on your performances, so you understand what's going on, and you can also do predictive analysis for if I have 3 pumps and one of them fails, how is that going to impact everything down the road? Although we're not using the traditional approach of bringing a performance map for each of the different components, because those are going to have interpolation and extrapolation errors. So as you're looking between speed lines or outside of the map, you don't necessarily know how accurate you're going to be, and sometimes you can be completely off the map and really have no idea that is the case. Here, when you try to solve a compressor that's going to be in the choked region, that simply is going to tell you that it's choked or it's not going to solve, and you can figure out that kind of things very, very early on. And really, the integration allows you to do iterations between design and analysis tools very, very easily. And that's really something that we've been striving for right from the beginning. So now being able to integrate this with the system level modeling, doing a direct export of the flow path to the rotor dynamics module, simply just expand those capabilities significantly. We had a service client that works heavily with steam turbines, and when we got to talk about the profiling tool, there was just radio silence from them. So I was like, you guys okay? Like, is it making sense? We're like, yeah, we just have a hard time wrapping our head around that, because everything that you're doing in here, we use 11 different tools to do it. And that's just a process that is mind-boggling in terms of inefficiencies and in terms of time, and in terms of making sure your fluid properties, your material properties are going to be consistent, your different models for calculating performances, making sure the geometry is going to be correct, making sure you're not messing up the units from one tool to the other. If you're doing it manually, making sure your digits are entered correctly. We have a software platform and a solution that is going to address those challenges and make sure that everything gets to talk to each other the way that the physical hardware is going to.